Okay, take 35. This is for reinforcement learning. The project one, where we're doing a re-implementation of Richard S. Sutton's paper titled Learning to Predict by the Methods of Temporal Differences. My re-implementation is actually done in a Python notebook. This is actually what I'm presenting here as well. I've tried to include text as well as code. So here's the random walk, for example. In that case, I think that's fairly straightforward. The biggest difference that I have is that I actually included the entire sequence vector instead of just the 5 intermediate states. So the terminal states are included here as well instead of just a z value. I found it a little bit easier to implement. The training sets here, 100 training sets, 10 sequences, of course. Moving right along to the temporal difference learning algorithm. This was actually a little bit more difficult to implement than I had hoped. Especially with some details missing, like what the convergence function should be, the difference between the incremental and the batch update, where we're actually updating, just accumulating delta W's here, and then after a full sequence is ran, we're then actually just updating the weights. That's the difference to the incremental update. We're actually just constantly updating the weights here. The figure 3 that I got the result is actually pretty close to what Sutton got in his paper. The root mean square error is a bit lower than what he got. I think this is probably related to computing power, maybe floating point precision back in 1988. He probably worked with a 32-bit machine and 32-bit floating point precision. Nowadays, everything is 64-bit. This is also what I'm running here. There might be other factors having to do with the convergence function, maybe the alpha value. I used 0.01 here. Sutton doesn't actually go into much detail about it. Figure 3 and 5. So 3 also is fairly similar. I'm actually diverging here a little bit quicker with lambda 1. I also don't see this crossover between 0.8 and 0.3 here. But this is probably related to the same kind of factors that I mentioned above. Figure 5, this is probably the biggest deviation, is that I don't get this dip here. I actually have a monotonically increasing function. And that's probably related to the same reasons. I actually, between the different experiments, I didn't see much in terms of assumptions that I had to make in differences. So that's it. Thank you.